Okay, people. So, welcome to the third and final half day. Hopefully, the last 2 days have been okay, been beneficial. Uh, Having two tracks, 3 different days, it's kind of difficult with the agenda to keep it straight. We not only forgot Mikhail's name in the agenda, rather also I mixed the ordering of the acronyms. So as you can see, what we're going to talk about is zCX on ZD&T, not the other way around. Mikhail, go ahead.
Thank you. Well, about a year ago, a bright manager at a company I'd done some work for asked a simple question, which set an interesting challenge. And the answer to his question was a new kind of mainframe application using some of the newest technologies available. So I'm not going to talk about DevOps. I'm not going to talk about scripts. I'm talking about an architecture, a project, and a lot of new technology needed to meet that challenge. And I got 107 slides, so I'll rush through most of them, and you can return to them because I tried to be very technical in the slides. So all the things we've done for configuration and settings and so on is documented here if you want to try out the same thing. So these are the headlines. And this is not something running on BEC. This is a presentation about a project that was purely a proof of concept, a laboratory project. In fact, it was done last year while I was still working at Exact Consulting. It wasn't finished completely, so the last few slides does not provide the success, but almost. And I think it was due to the lack of advanced networking skills. But I hope that the concepts and the experiences here could be useful for you. So it was a small project, but as you know, help will always be given at Hogwarts to those who ask for it. So this is just a grateful list for some of our generous helpers. So let's first describe the challenge. The question was, can you run Windows on zOS in order to run a hybrid application with some code in CICS calling, some code in Visual Studio Code, but without the network latency? And why would that be interesting? Because some critical business code in the future will be easier to maintain as C# and .NET due to staffing issues. I know we have a long discussion about, is it easier to get a Java programmer or a C# programmer than a COBOL programmer? Is it easier to get a good Java programmer than a good COBOL programmer and so on? But anyway, this is an issue, and the question was, can we do this? And this code, which will be ported from the mainframe, from old mainframe assembler code to C# and .NET, will be called all the time. It's an important part of the application. So we cannot afford network latency to a server on another platform. So the best answer seemed to be zCX, zOS container extensions. This was not yet available at the shop who asked the question, but that's not a problem when you have access to a ZD&T system. So this was built on a ZD&T system owned by Exact Consulting. What do we talk about with a hybrid application? This is often referred to as a cloud-style application. And you could call it a private cloud, but to me, a cloud is just somebody else's server. So what I want to talk about is a hybrid application on a mainframe. It's an application which uses existing data and existing business logic, but adds new functionality from other platforms. It can be existing packages, APIs from other companies, or any functionality that can be developed and maintained faster, easier, and cheaper elsewhere. And of course, when we're talking about this, we should also consider if we can open our own application and data for our partners and customers, if it makes sense to the business. Right. So this is a simple architecture drawing of the logical model of the hybrid application we suggested. What we have here is a COBOL program running in a CICS region. It uses a REST call to call some logic in a C# application running in a Docker container in a zCX instance. How difficult can that be? Well, it can. Let's first talk about zCX. Let's try to position zCX from a mainframe point of view. zCX is a runtime for deploying Linux programs as Docker containers on zOS. If you build a Linux program, you can normally package it as a Docker container and deploy it to zCX. What we have on this drawing is an imagined mainframe with 3 LPARs. The first LPAR is running ZVM with a ZLinux guest and a Linux application inside it. The second LPAR is running ZLinux natively with a Linux application in it. And the third LPAR is a normal LPAR with runtimes inside it, with CICS regions, IMS subsystems, USS runtimes, DB2 store procedures, WebSphere, and a new runtime called a zCX address space. And inside that, you can run a Linux application also. So what we're talking about is different from running in LPARs as VM guests, and it's different from running on USS. What we have here is a Linux container, a Linux runtime, separated completely from the outside using Docker technology. And in principle, any Linux program that can be packaged with Docker should be able to run here. And if it can't, if it's not your program is a problem, then tell IBM and have them fix it. So, looking at a normal LPAR, here we have just 3 different runtimes. So seen from above, from outside, zCX is just another runtime like a CICS region, like an IMS subsystem. So, in theory, to configure and run a zCX region should not be that different from configuring and running a CICS region. But of course, as you know, in theory, there's no difference between theory and practice, while in practice, there is. But I'm talking Linux. And the challenge was to run a C#.NET Windows application. So what we needed here is another building block, which is called Mono. Mono is a runtime that allows C# Visual Studio.NET code to run on Linux. And the very smart people at a company called Sine Nomine Associates, and especially a guy in Australia called Neil Ferguson, has ported Mono to Linux on Z and supplied a Docker implementation. So you can go to Docker Hub, which is where all the Docker containers live, and pull down a Mono container which can run on zCX. It works nicely. And then we can shoehorn a Windows application into it. So if we take the logical model from before with a CICS region and the zCX instance and translate it to a physical model, as I said, we are not running on real hardware, we are running on ZD&T. So what we have here is a bit overwhelming picture with 11 layers in the configuration. And if you start from the right, you have a physical box, VMware on top of that, a virtual machine, and then you have the ZD&T package with hardware emulation, and then the 5th layer is a zOS system. Then continuing, we have CICS regions and zCX instances, and on top of CICS, inside the CICS region, we have a CICS application program, and on top of zCX, we have Linux, then we have a Docker engine, then we have a Docker container, then we have Mono, and then we have our applications. So I'd just like to stress, this is not suitable for performance testing, but we were able to do a proof of concept with a couple of simple programs and a lot of plumbing. So the outermost layer we have on the logical model was a zOS system, and its maps to layer 5 from the bottom of the physical model. The CICS and zCX runtime maps to layer 6. The Docker container is at level 9. The Docker application at level 11, and the CICS program at level 7. And the plan, it was really to start from the beginning and continue until we reach the end, to configure everything and then do some coding, and finally to build and to run it. ZD&T is an zOS system running on x86 hardware on top of a Linux operating system, and it's a great platform for projects like this. So this was the device map for the ZD&T system we used. So on Linux, we required 8 processors, 1 for Linux itself, 3 general purpose CPUs, 3 SIP processors, and a crypto processor. So this is what the device map will look like, and this is a ZD&T configuration file. Then we installed a fresh ZD&T system with zOS at version 2.4, and we only did a minimal configuration of it. And from this version, with zOS version 2.4, zCX is ready to run. And you can find all about our ZD&T configuration experience in the link on this slide. Also, the zOS-MF parameters, which we did where we had to do some tuning, because zOS-MF is needed for installing zCX, and zOS-MF runs very, very slowly on a ZD&T system. On the network side, we just needed 4 new statements in TCP/PALM's profile, defining a virtual IP addressing, a dynamic virtual IP addressing. So the dynamic Viper, you define it, you activate it, and it works. Then you need to create a ZFS file system, because the zCX container image is 2 GB. So we defined a linear VSAMP dataset with 100 cylinders as primary and secondary extents, and put it on its own volume. Added the mount statements to PALMlib. And it needs to be big, and you'll find out how big it is when you start to use it, because then zOS has to format the linear dataset, which takes a lot of time, especially on a ZD&T system. Of course, you need some regF definition, you need to define some user and some groups, and you need to define a SSH key pair for the administrator user ID you define. So the zOS configuration was minimal, and then we went on to configure and to run the ZMS workflow to deploy a zCX instance. And zCX provides a workflow definition, which I found no errors in it. So the first we did here was log on to OMVS using the zCX administrator user ID to create a key pair, which looks SSH keygen. Not too complicated. And then it responds with this nice drawing and says, I have generated an SSH key pair, and it's stored in a directory where you can find it. What we did then was to take the public key and cut and paste it into the configuration defaults in a file called workflow variables properties. Otherwise, you will have to cut and paste it every time you want to deploy a new version. So if you put it in there, then there's not much configuration to do. Actually want to run the workflow. So the parameter file is called workflow variables properties, and you copy it from user LPP directory to a var directory. Edit it to contain all the necessary variables to speed up automation, and that's IP addresses and name of your own system, etc. Our source is available on GitHub on the link given here. What you do then is you log on with a browser to zOS MF, zOS Management Facility, with your RAGF user ID, and this is the way to provision a zCX instance. It takes a lot of patience to run this workflow, but it's not very difficult. And as I said, we got some help to tune it. You can find it in the cookbook, which I gave you a link to. So in the browser, you go in, select workflows, actions, create workflows. This is a display of the workflows which we have already run. So you create a new one, action, create workflow, use the IBM supplied provisioned XML and your customized variable and tell it what is the name of the system. And you say assign all steps to owner user ID just to avoid clicking 100 times later. And then you can see the new workflow with a lot of steps, which is commands to different things, and most of it is job steps and jobs, which defines data sets and copies, configurations, and so on. You select first step, action, perform, check all the variables, which should be okay if you set them right in the parameter file, click finish to customize, and then you select all the next steps, action, perform, run, and then it runs and runs and runs with an awful lot of copies and submits, and you end up with everything defined and configured. So now we're ready to start zCX, which runs as a started task. This is a command which you use to start an instance called zCX 0001. It takes a while to initialize, and especially the first time after deploying an instance, it needs to format the linear data sets. So it takes extra long time on a ZD&T system. But eventually we will get there. I think it's on my system, it took 46 minutes to start the started task with everything it needed to do. You can drink a lot of coffee in that time. But eventually we got there. We got a message which says, please connect to IBM zOS container extensions Docker CLI. We have it here. And that means we are up and running. The server is listening on an address called blah, blah, blah 199 on port 8022. So now we can end up Unix system services to create a personal zCX user ID. We had the administrator user ID, which was defined to RAGF, but this user ID is not known by RAGF. It's only used inside Linux. So you have a Unix command here, which says add a user in group Docker called my user ID. No, it wasn't, but. And then you can log on to zCX, either through OMVS with this command, SSH, zCX ADM1, that's the user ID, add the address with the port name. Or you can log on from IDZ, opening a USS shell on a zOS system with the same command. Or you can log on from a Windows shell using the same personal ID. There will be some SSH key exchanges but they are not shown here. But what you get is welcome to IBM Z Container extension shell that provides access to Docker commands. What you can do also is if you run in ITZ, you can define as SSH connection to zCX. If you've done that, then you can access the file systems and the shells on zCX directly. Like here. So you see this is the zCX system which you can access like a tree. Now, we have zCX running, we need some Docker containers to run inside it. And it's proved more difficult to deploy to zCX than we had expected. We could not connect directly to the Docker.com hub where all the Docker containers live from zCX. And this is a connectivity problem which we didn't solve, and we didn't find it that important at that point in time, because then we just downloaded the containers we needed to a workstation and uploaded them again to zCX. It ended being a problem in the end, returned to that. So we installed a Docker desktop on Windows as an intermediate. And you can log it on and create an account, which doesn't cost anything, and then download the installation package from the link given here, and then install Docker desktop. And when you run it, it would say no containers running, but then you can start put containers into it. There are a few parameters which you should set here, and we have put them here. So now we have zCX, we have Docker desktop running. We could now pull an existing Docker image and deploy it on zCX. And the purpose of this is to demonstrate that the zCX installation works. And actually there are over 200 images, nearly 300 images available for what they call Z390X, which is zOS Linux, either zLinux or zCX, available on Docker.com. And the Redbook, which we used to help us, recommended to install Nginx, which is a simple web server and very easy to install. So we pulled it down to the workstation and then pushed it up to zCX. And these are the commands, and they are typed Docker pull, Docker save, Docker load, Docker run, and we need some copying here. And when you've done that, and when you have said run Docker, then actually this web server is running in a Docker container on zCX. And if we look closer here, we can see that this is the address blah, 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 199 of zCX, and then the web server was running on port 8080. And here I was going to ask Scott if he got all the acronyms right, but I hope you got it now.
They were recording, so I'll get them afterwards.
Okay. So the next step we needed to do was create and deploy our own C# program. So what we did was to install Visual Studio with Docker support from Microsoft. And these are the addresses where you can get Visual Studio, and good advice is on the link in the middle. And if you want to use our project source, it's available on GitHub. So here you have Visual Studio installer, and it runs, and you say create a new project. It has to be an ASP.NET Core web application. You give it a name. You select a template called API, and you say enable Docker support and run it on Linux. And then it creates a project with some configuration files and some source files. and we go into the source file called value controller CS. And there you have a very small program which gets called with an API, with a REST request, and it returns a couple of variables. So what we did was just to change it something more. Hello from a zCX REST service running in Docker, running in zCX, running in zOS, just to demonstrate that we've been here. There are some launch settings which you can study if you want to, for running in different situations in Windows web server or in Docker. So the first thing we did was to build and run a program in the built-in Microsoft IS Express server, which is a web server running. So here we run as a Windows application on Windows. And running it opens our browser and displays the response. Hello from a zCX REST serving running in Docker, running in zCX, running in zOS. Well, if you have another kind of bus than mine, you might have this situation, and I'm not sure how many hours it actually took to get here. But think of it as a first step only. Now we turn to Docker. And Docker runs as a build engine on your workstation when you have installed Docker and desktop. It also has a run engine, of course. The build engine reads a file called Dockerfile and executes each statement in it. Visual Studio generates a Docker file for you when you select Docker support for a project. So when you ask to build for Docker, it creates a Docker container for Windows, but of course not for Linux on set. That's another task later on. So the build process for Docker is defined in this script called Dockerfile, and really just a series of statements executed sequentially by the build engine. And it creates a large image for both for local debugging and a smaller image for deploying and running in production. And I advise you to study the Docker file carefully and use tutorials and documentations to understand it better, because you'll need to edit it like we did. The most important statement is the first one, it's a from statement, which says which existing base image are you adding your program on top of. And in the provided version from Visual Studio, it was Microsoft.NET Core ASP.NET. And this is fine as long as you use a Docker platform that supports .NET, but we need to do something else for our platforms. Anyway, this is the generated Docker file for Windows. So you have from Microsoft.NET, some directories, a port, and then the statements we have here. We have a run.NET restore, run.NET build, run.NET publish, and the last one in 21 entry point is the one which actually runs the program. So when you run it, it starts a build using Docker. First, it finds that the desktop has been installed, that the desktop is running. It checks that the system you're building for is actually the one you have. It says the images are ready, the container has started, and then it opens up your browser again. This is the same response as before, but it's not from a web server now, it's from Docker. And if you look inside Docker Desktop, you can use that to monitor your container. It says now we have a running container called zCX REST Service 1. And there are views to view the log and inspect the settings and so on. So now we have a C# program running in Docker on Windows. So let's continue to Docker on Linux. And this is not so simple because Docker is not just Docker. Docker supports several architectures. And Visual Studio, I would say naturally doesn't support Linux S390X architecture out of the box. For some reason, Microsoft does not support mainframe code directly, but you can see the existing support documented at the links here, and there are help to be found. So what we did now was we compiled a .NET program for Docker. We borrowed some code from a guy named David Bolton, and this is a sieve of Eratosthenes. So look here, which finds all the primes from 1 to 1000. And we compiled it not with .NET, but with a package called Mono. The Mono runtime enables us to run .NET applications on Linux. So we compiled it with a compiler provided by Mono called MCS. And Mono is a software platform designed for cross-platform application. It's actually provided by Microsoft, or rather, one of the subsidiaries. And it's their opening to make it possible to run .NET applications on Linux. So we installed Mono from Windows from the link given here. And later on, we'll return to Mono for zCX, which is contributed by Ferguson and Sine Associates. So we wrote a very small Docker file, or stole it from David Bolton, only 4 statements in the Docker file from Mono, latest version, add the application, which adds the source, and on top of it, run the compiler MCS for zCX, and then the command Mono runs the executable. So when we say Docker build Ceef in the middle here, it runs the 4 statements and builds the application. And when we say Docker run Ceef, then we actually get the result 2, 3, 5, 7, 11, 13, 17, and so on. So now what we have done is to run this program, this .NET program, in Docker on Linux, which runs on a Linux emulation provided by Windows 10. But this would not run on zCX because it was compiled on x64 on Intel platform. And we got stuck here and then consulted Neil Ferguson of Sine Nomine. And he said, you need to start from an existing S390X specific Docker images. So they recommended an image called Clefos Mono as a starting point. And this one implements Mono and runs on zCX. So to run the same program before we see of Eratosthenes, we pulled the Clefos Mono package from Docker Hub, saved it as a tar file on our machine, uploaded it to zCX, and uploaded the source to zCX. Then we opened the shell in zCX and says Docker load, which loaded the tar file into Docker. Told Docker that version 6.13.0 is the latest one, which it needs. And then we said, Docker run Clefos Mono. So what we do now is we have started a Docker container with Mono in it, and it opened a secondary shell inside zCX. So now we have Mono running in Docker, but we need to push the source into the container. So we opened another primary zCX shell and said Docker PS, which containers are running. And then we could copy with the Docker copy statement from zCX into the running Docker container. Doing that, we could go back into the secondary shell and run the compile, MCS, and run the program, and it actually ran. So what we have accomplished now is to build and run a simple C# program in Docker, in zCX, on zOS, on ZD&T. But this was a simple program. We haven't yet gone to the point where we could build our REST service and call it from CICS. Just to map where we have been now, you have here you have the zCX or ITZ shell, which maps to this layer. You have the zCX shell, which is a Linux running on zCX instance. And you have the secondary shell, which runs on top of Mono, on top of the Docker container. So 11 layers, gentlemen and ladies. The next part of the plan was to compile and build a complete .NET project as a REST service in Docker in zCX. And this did not succeed. We took the Docker file from the Visual Studio project, and then we changed it to the from statements to from Mono latest. And when we tried to build this last year, it failed because at that point in time, the support for .NET and Mono was incomplete. And we stopped there. But recently, there are new versions of both components. They've been updated. So now the Docker build statement actually works. But what happened to us was because of our network issues, it stopped and timed out because it needed an outgoing network connection to Docker Hub to fetch more packages to put in when you do the build. And we found that we could ping our own domain from inside the zCX shell, but we could not ping outside it. So it has to be a network problem, which we didn't have the time and the skills needed to solve. And in principle, we could have loaded the packages we needed from Docker on the PC and up again, but really it wasn't clear to us exactly which packages we needed. So we didn't try to do that. So the build failed. We didn't complete this part of the project, but if you want to go this way, then I'm sure that in your installations, you probably have sharper network people than us. We tried to build it on Windows, upload it to zCX, it refused to run. And we knew then that we had to compile it on the target platform. So we could copy the entire Visual Studio project to zCX and use the Docker build command, but it didn't help us. There is also a Mono xbuild command which works on zCX, but it seemed to build nothing for us. As I said, it worked, but it timed out. So the final part of the project was to call the C# program from zCX, in zCX from CICS. And if you know CICS#, this was quite easy. So we wrote a simple CICS COBOL program, actually with 5 CICS commands: web open, web converse, web close, send text to have the response back to the screen, and return. And this is really all you need for a REST request inside CICS. What it does is, on the surface, it's used TCP/IP, but because it's running on the same host and it's using hypersockets, actually it's not running across the network, it's running cross memory, so it's very fast. It doesn't have network latency. And if you're going to build this in a real-life application, then I expect that you would use the new asynchronous CICS API in order to call the other components on the other platform without being hung up. And the source of the COBOL program, of course, is available on GitHub as well. So I believe we have proved that you can run a hybrid CICS and Windows application on the same zOS system. And I think that this could set the scene for a brand new family of applications. And you have the advantages of cloud solutions, but you can run it safely and effectively on a mainframe system. You have the source on GitHub, and you can, if you find the solutions or the rest of the problems, you're very welcome to share it with the world. So this is what I had intended to talk about, and I'm too cautious to do any demonstrations, but let's hear if there's any questions.
All right, so go ahead and unmute and pose any questions or comments.
Okay, I have a question, Michael. Hey, Michael, this is Paul Pilotto speaking. It's been a long time, right?
Hello, Paul.
Hey, Michael. So this was to, in fact, I would say consume a service that runs in a Docker container from a CICS transaction, right? So the CICS transaction is consuming a service that runs in a Docker container. Would
Yes.
would you expect it bidirectional? Meaning, for example, I think most of the client applications today, I think they have like a VS Code or C# front end, which probably wants to access CICS transactions to access maybe DB2. So which is the opposite direction. Would you think that could be working as well? Or what would be the limitation in that architecture?
It would probably work, but I don't have the imagination right now to see a use case for it, because what you do today is that you run from your Windows or whatever server farms, and you have all the possibilities to call CICS with REST and transaction gateways and 100 other ways. So I think that this is probably be carrying code to Newcastle. But anything can be imagined, of course.
Yeah, I was thinking in the context of automated testing, but yeah, you're right. Maybe the production architecture is maybe not the right way to do unless you want to try to reduce the latency of the network as well. But in the context of test automation, that this could be a use case maybe in order to run the end-to-end hybrid application completely on zOS. But
oh yeah, that would be a use case. That's interesting. Yes.
Thank you, Michael. It was a really good presentation. I must admit that I took some pictures. I'm sure that we will get access to the presentations, but I really liked the way you presented this. This is great stuff.
Thank you.
Hi, Michael. It's Fleming. Again, awesome presentation from you. And I'm sorry if you already answered this in the first couple of minutes, because I was struggling to get into this meeting because of another one. So I missed your first 2 minutes. My question is, it seems like the Mono project is very key to this setup. That's really what's enabling .NET on C. But what is the state of Mono? Is that something that, in your opinion, you would risk to run as a production workload, or is this more for fun?
Well, Mono as such is backed by Microsoft, because Microsoft wants to have their stuff running on Linux, of course. It's as important for Microsoft to run Linux as it is for IBM. And the weak link, of course, is Mono on zCX implementation. And what I would do if I was a customer who was going to embark on this, then I would get the support from the Synology people and make sure that because they have the expertise, they have the VM expertise, the ZLinux expertise, the Mono expertise. And if you run into a problem, then you can pay them to fix it, because Mono as on ZLinux is an open source project. So doing that, I would say that I would do that. I would do that in production. Yes.
Yeah, thank you.
But that, of course, that goes for in any open source. That yes, open source, you can steal it from the internet, but if you want to run it professionally, then you either need the skills yourself to fix, or you need to have a service agreement with somebody who can. If you happen to have a question later on, then of course you can email me and I'll be happy to answer if I can.
Is your email address on this presentation?
Yes. Yes.
Yep. Okay. Good to go.
This is my address at BC. As you know, I used to work for Exact until with the Enterprise Modernization department folded. And now I'm working part-time for BC with an out of librarian into Git project. And I'll be working there for a year or so. And afterwards, if I stop there, then you have to catch me via LinkedIn or something like that.
Okay. Do we have GSE? Do we have this your newest email address?
You have my private email address
Okay.
on GSE. And
Okay.
that.
So other comments?
So just one more. Really good presentation. I'm just curious, what is your next steps from this POC in terms of rolling anything out to production, or do you have plans, or are you about to create plans with regard to this yet?
As I said in the beginning, this was a question from a very bright manager at the company I used to do some work for. And I know they are considering this seriously. So if they decide to go this way, then I suppose I'll be doing some work with them to do this in practice, because it's a key part of their application. It's a financial institution, and it's something which I think it's written 30 years ago in mainframe assembler, and they want to move it to somewhere where they have better chances for maintaining it. So it could be a very important thing for them. But they have to decide on doing it, of course.
Hey, Greg, do you want to go into unmute and talk about your results?
My test was very, very simple. I mean, it was really just an install of zCX, and then I just did like a Docker run hello world. I think, Michael, you mentioned you had issues connecting to Docker Hub. I ran into the same issue. What resolved my problem was ensuring that the devipa address that's used for zCX was in the same subnet as TCP/IP on zOS. Once I did that, I was able to connect to the Docker Hub. So that may or may not help your issue as well.
Okay, let's exchange some emails afterwards. So
Yeah, sure.
thank you.
Thanks, Greg.
No problem.
So people, we still have 10 more minutes. More comments? Questions? Well, Miguel, I'd like to say I thought it was an excellent presentation also.
Thank you.
So people, I will, if there's any other comments, then I will close up this, and in 9 minutes, starts the next one.